Hello. In my last video, I have introduced the concept of joint distribution. Hope you have looked at those video and the chapter in the book by Larry Weserman, probability all of statistics. So let us just recall the joint distribution refers to the probability distribution of two random variables observed together. So suppose x represents height and y represents the weight of a person. So this is like studying the probability of two variables simultaneously of the height and weight for each person. Now the probability distribution of such a pair of random variables will either have a density, which will be a function of two variables x and y, or it will have a probability mass function, which will be probability x equal to x and y equal to y. So in either case, this is not a probability, as you all know that this is a non-negative function integrating which we calculate probabilities, but this is a probability statement, and here we are making a probability statement about two random variables at a time. Of course, if one of them is a continuous random variable, then you know that this probability will be 0, so you can no longer talk about the probability mass function, or this joint probability statement will be 0 if any one of these random variable is a continuous. So when these random variables are continuous, then we have this joint density. Of course, you can ask here that what would happen if one is discrete and the other is continuous. Well, that is a bit tricky and interesting. That would of course depend on what is the other. Suppose x is continuous, y is discrete, then you can have the joint distribution can be continuous. Okay, but then that is something I would reserve for later. So for the time being, let us assume that both x and y are discrete like here, or both x and y are continuous. In that case, you either have a joint density or a probability statement like this. So I will write here, this is for continuous random variable, and this is for discrete. So that's it. We are studying with, so joint distribution refers to the situation where we are studying two random variables together. Now for simplicity, I am mentioning two. You could also talk about joint distribution of several random variables together. For example, you could talk about the joint distribution of x1, x2, xn. You could talk about the joint distribution of x1, x2, xn. Of course, in that case, this will be a function of how many variables? I think you can guess. Then it will be a function of n variables, and hence similarly this will be a probability statement on x1 equal to x1, y1 equal to so x2 equal to another number, and all the way up to xn. So this way, but it is enough to understand with two random variables, then you can understand everything for any finitely many random variables. So if I want now to know what is the probability distribution of x, or what is the probability distribution y, then they are referred to as the individual probability distribution. They are called the marginal probability distribution. So the marginal refers to the distribution of one random variable at a time. So you can have the density or the probability mass function depending upon whether x is continuous or discrete, and similarly you will have the distribution of y in terms of density or probability mass function depending upon whether x is continuous or y is continuous or discrete. Now here is an interesting thing that I wanted to tell you. If I give you this joint density or this joint probability mass function, then you can get the marginal distributions. So can you guess how? I will write down here. This will be integration over all values of y the joint density of x and y, integration is over naturally y, and this one will be equal to summation of all values of y. So let us say in some I'll tell you what this is. This probability x equal to x and y equal to y, where S is the set of atoms. So this is you try to understand this. Suppose, so this is for the continuous case and this is for the discrete case. So how do you get the marginal density? Just focus on the continuous case. So given a joint distribution, you can get the marginal distribution by integrating over the other variable. So you are interested in the distribution of x, you integrate over y. Similarly, given the joint when x and y are both discrete, you have the joint probability mass function. From there you can get the value of probability x equal to x by summing over these probabilities for all values of y. What is the set S? S is the set of atoms, that is set of all values of y, which takes positive probability. So this is how from marginal distribution you can get the from the joint distribution you can get the marginal distribution. So I have written this formulae for the marginal distribution of x. I leave it as an exercise to complete this part. That is, if I give you the joint density, from there get me the marginal density of y, or if I give you the joint PMF, the joint distribution of x and y when they are discrete, then get me the joint probability, marginal probability of y. Okay. So I would ask you to do some exercises. Like in the last video, I had given you some examples of the joint density function from that book and from the joint probability mass function. If you remember that 2 by 2 table, so I would request you to compute the marginal distribution of x and the marginal distribution of y for those examples. Now the third thing that I want to talk about here, this is perhaps a bit tricky. It is called the conditional distribution of one variable, say x, given the other variable is fixed. So here we are, let us go back. So joint distribution arises when you have more than one variable. So conditional distribution means you are studying one variable, or you are making a probability statement about one variable, keeping the other fixed. So suppose you are studying height and weight, like suppose you fix the weight of a particular person and then make a probability statement about his height. So this was more easily understood when I look at the discrete case. That is, I am interested in the conditional probability of x taking this value number y given y equal to y. So this is you remember that probability of a given b is equal to, what was the formula? It was the ratio of probability of a intersection b divided by probability of b, of course when probability of b is positive. So we are using that formula here. This is the joint probability divided by, so a intersection b, this part is a, x equal to x, and b is y equal to y. So a intersection b divided by probability of x. So this is called the conditional PMF of x given y equal to y. And then you can have the conditional density also defined in this fashion. So conditional density is basically the ratio of the joint distribution by the marginal distribution. So when you are fixing y, then you have to divide the joint density or the joint probability mass function by the marginal distribution of y that is marginal PDF of y or marginal PMF of y. So whichever is fixed, that will come in the denominator. So I have written the formula of the probability density function and the probability mass function of the conditional distribution of x given y equal to y. So I would write you like you to try out the other thing, the conditional distribution of y given x equal to x. So when you are fixing x, I want to find you the conditional density or conditional PMF of y given x equal to x. So just the hints, we are basically using this formula. So then you have to divide the joint density. This will be same in the numerator, either it will be the joint PDF or PMF divided by what, that I leave it for you. Thank you.